So some background about me. I'm a systems engineer. I have about 20 years of experience working in tech. My main focus is scaling systems and infrastructure. I love mentoring and growing new technical leaders. And until recently, I was the technical leader of the SRE organization at Elastic, responsible for the operation of Elastic Cloud. Currently a distinguished engineer in the observability space at Elastic, and I'm building products for the SRE practitioner. What we are covering in this session, I'm going to provide some operational environment and business context. And I think that's important in order to understand what's the motivation for a company to get hundreds of engineers on call, when in the past only a small SRE team has been the first line of defense. We'll cover some points around planning for change and how to prepare for such big changes in the life of engineers and in the design of systems and the capabilities around operating those systems at scale. We'll go a bit into some detail around why it's important to define service boundaries and be clear around what the limitations of a system is. And we're also going to cover the design and operation of a system that monitors SLOs at scale. Lastly, we're going to talk a little bit about product launches, how we tie them with production readiness criteria and operational maturity. And also what it means to actually empower an engineering team to carry the pager for their services. We'll close with the takeaways and lessons learned. So some business context. Elastic is generating about 1.26 billion. That was past fiscal year. And Elastic Cloud is growing at 32% year over year. So it's moving much faster than the rest of the business, and it's a significant part of that business and likely will overpass every other stream in the next year or so. This is the experience that someone gets when trying to create a new Elasticsearch cluster in Elastic Cloud. Elastic Cloud is a SaaS offering by Elastic. It allows you to manage an Elasticsearch cluster and consume capabilities like vector search, hybrid search, semantic search, and also run solutions like security and observability. As you can tell, it's very complex. It's very complex to come up with a topology for a cluster for one's need, and you almost always need to have some level of expertise if you're operating that system at scale. Elasticsearch is a great product. Elastic Stack is great, but it's not a simple one. It's a rather complex system to manage and design for. And while we've made what I think is a great hosted experience, it's still too much to ask for a practitioner to know all of these things beforehand, before embarking on a journey to create an application or satisfy a need in security or observability. So we need to come from this to that. You are no longer required to know exactly the topology of an Elasticsearch cluster that would satisfy your needs at your given scale with your specific user patterns. You are just prompted for just 3 options. What type of solution you are after? Are you after search? Right? Are you after observability or security? And then you just select the region that you want the project to be deployed. Now that's quite a bit of a change. What does that change mean operationally? There's a big responsibility and business model shift. In the current hosted offering of Elastic, the customer is co-responsible for aspects of the operation of their service. They're responsible for monitoring their Elasticsearch cluster. They're responsible for making scaling decisions. They're responsible for setting auto-scaling threshold. They're responsible for identifying the best hardware that they want to use for their specific use case, and they're also responsible for managing the lifecycle policies of their data. In the new offering that we are designing and will be getting to general availability soon, the customer must not care at all about the operational aspect. It's completely shifted to the team that's building the service. So physicality is abstracted away from the customer. They no longer need to care about number of nodes, number of cores, RAM, storage, all of those things do not matter anymore. They just need to focus on their exact use case and not be bothered about all the other things that are in the operational space. So you need to understand that by operating tens of thousands of Elasticsearch deployments and also having this core responsibility with the customer, it means that there's a lot of shadow work happening behind the scenes to support the system. We've distributed a lot of work in centers of excellence around observability, security, and search that are on the customer side. Experts in the system or folks trying to be experts in the system operate those things with us. In the new model, Elastic is solely responsible for the operation of the service. And with that, scaling and reliability becoming system properties and are not offloaded as responsibility with the customer. We're also changing the way that we charge, moving away from just resource-based pricing, where you select a number of cores, RAM sizing, number of replicas, and what have you. You are now just charged on consumption, how much data you get in, what type of retention you select, and all those things. In that, business and customer incentives align. It means that whatever improvement we bring to Elasticsearch to make it faster, whatever improvements we make to make data more compact on disk, that actually is for the best of the customer. We can lower prices and without harming our revenue. Right? In the past, if we had these types of improvements, we could also see headwinds, like less resources needed for the same type of work. That might mean that some customers might scale down. This type of tension didn't make any sense. So we wanted to align the business incentives with what's best for the customer. So in order to get to that journey, we had to come up with some architectural changes to support that new model. I won't go through all of those things, it's a wall of text, but it gives you an idea of how many changes we had to go through and how many new systems we had to build in order to support the new serverless offering side by side the other offering. So we are not retiring the previous hosted model. That's a great model, it works fine, customers love it. It's still going to be there. We're just adding the new serverless model on the side. That means more systems to manage. Right? That means a lot of new intellectual property to be created. And I'll just go through a few of those things. We're replatforming to Kubernetes. In the previous offering that I mentioned around the hosted offering, we have a proprietary container scheduler system that has been operating predating Kubernetes, and we've been growing and growing and growing it. And we chose not to further invest on that for the new offering, but come up with something else, possibly contributing upstream with Kubernetes. We also elected to try and separate compute from storage, separate ingestion from search, and this is how stateless Elasticsearch was created. We are also now required to scale on multiple dimensions and do it in a way that does not disrupt any customer use case. We also had to come up with some way to have a system for global configuration with a recovery point objective of 0. That's tough to do. And also get to a window where we can have a global control plane that has a regional failure domain, like we can swap between regions in case of a catastrophe. Not only that, but since we are responsible end-to-end for customer happiness on individual deployment level, we had to come up with a system to infer customer happiness end-to-end on a per individual customer basis. That means that we are no longer just happy to monitor things that aggregate. Each individual customer matters, and a small use case that has a bad time should not be drowned by the sea of happiness of other larger customers. We need to bubble those customers having a bad time, regardless of their rate of throughput compared to other customers. And with that, we had to come up with improvements in production readiness, change management, and safety. So at what scale are we talking about? So Elastic Cloud is deployed in over 60 regions spread across the globe. Serves tens of thousands of customers running Elasticsearch and some solution on top. And it's a team, at the time when we embarked on the journey, there were 58 SREs staffing the team that was on call as the primary response and incident commanders. as you can tell, that SRE team could never scale to support that new operating model. We couldn't possibly see a future where all those tens of thousands of customers that used to have like someone being also responsible for their Elasticsearch deployment on cloud, suddenly we do all of that for them, right? And we shouldn't have to do that. The system should be designed in a way that self-heals, scales, operates smoothly, adheres to some service level agreements, and provides a happy experience for the customer. As such, the engineering teams building the system must be the ones that carry the Bacher. So what's next? When it was clear to us that we couldn't possibly, just by law of big numbers, train, grow the SRE team to support all of that load that we expected to come, we need to navigate the complexity of the solutions and also dispel some fear, uncertainty, and doubt in engineering leaders' minds. So we initiated a few sessions with senior engineering leaders, trying to seek alignment around engineers carrying the Bacher and being the path forward. That took quite some time. It was important that we engaged early in that journey. And once we managed to align, we had to determine who would be the initiative's leader and let them drive for a bit. We also had SREs provide consulting services to teams around what does it mean to be on call, how you structure an on-call model, whether follow the sun model works for you, whether 24/7 works for you, all those things. And we also had to navigate the complexity around local laws, labor laws, compliance, and also coming up with a plan to compensate folks for being on call. So we had to work not only with engineering leaders, but also HR, legal, and finance on that. And lastly, when everything was kind of figured out, we had to come up with a plan for a plan. And we need to put dates next to rolling this out. Once we had a relatively, we had some confidence in the plan, we started testing the waters with individual teams and folks that were willing to pioneer on being on call. And we started iterating on their observations and things that they were finding as problematic. What was immediately clear to us was that we had to draw a box. And your product or service capabilities would live in that box. We were very strict around creating a system that has a very clear boundary around capabilities, scale supported, properties, and be very transparent with our engineering partners and the field, the sales team, and the customer around what the exact capabilities, limitations, and quotas for the system were. That really helps because it can prevent customer having false expectations, especially in high demand use cases that we wouldn't be able to initially support. And that was okay, it wasn't a blocker because we could still direct them to our hosted offering if their use case could not fit in our new product line. With that, we also came up with a continuous improvement strategy in order to expand the box as we improve on automation, self-healing of the system, or when we start observing that specific customers exhibit a pattern that kind of fits in the box. What's the next step to do in order to grow the box, in order to cover them officially, right? The question came up from engineers around, hey, what classifies my service as being production ready, right? That's a good question. Like, nobody knows, right? When you get on some business, right, you enter and you become part of the SRE team, more often than not, especially in businesses that grow very rapidly over the years, some systems are already in production, right? Some systems you don't really control. Some they don't even have any SLO target, right? They kind of operate and behave in ways that you don't really know about, but you still need to carry the Bacher and manage them, right? So how do you get to a place from zero, let's say, just on your operational experience with the running system, to something that's more formal around a conformance list, a set of criteria that describes the bar that you need to meet in order to be production ready, production eligible. So we're able to provide some actionable guidance to service owning teams, following our experience mostly from a security background, right? What are a set of controls that we need to have in place in order to meet the compliance requirement, right? So we came up with a simple and efficient production readiness checklist with some sections like providing key documents and reports around the service, right? What's your disaster recovery plan? How often do you execute it, right? What's your service overview? What's the architecture looking like? Where is the supporting documentation? Where's your API spec, right? Give us some insights around your durability review. Have you done a threat modeling with InfoSec or security teams? What are the failure domains for your service? Those type of questions. And then going a little bit deeper, what are the operational mechanisms you use in order to actually support your service? And how often do you review them and in what venue? We also ask each and every service owner to come up with a set of SLIs that would inform us around the performance of their service, and a set of SLOs that would, at some point, at higher level, inform customer happiness, or the level of reliability that other systems can build up on top. Nowadays, you cannot have a new service at Elastic Cloud without completing that production readiness review. You have to have SLOs, you have to prove them over time, and then you get deployed in production. We also had some questions around change management, safety, scalability, and how you actually have a secure development lifecycle and how you test your software. Obviously, getting everyone to follow that production readiness review was not going to happen in a tight time frame to launch a product. So we had to take some other approach, be a little bit more lenient, and try to align the production readiness review checklists into a phased approach as we were launching out the product. So we came up with a 3 or 4 phased approach, depends how you read it. So we have a private beta for the product where we would onboard sets of friendly customers that were okay seeing some nasty bugs hitting them. And then through that process, close and iterate any open production readiness review items that the teams might have. We'd also establish all the processes around on-call and how to ensure that there is some incident response on high SLO burn rates. We exercise the muscle, and when we set a set of criteria were met around, for example, conformance to SLOs, operational load from tickets and events and incidents happening to engineering teams, when we were comfortable with that, we moved to the next phase, which was coming up with a public beta. First, gated, like we would control the number of customers joining and launching services under the new product label. And then when we're happy with how things fared, we open it up to the world as a public beta. We are now in the phase where, likely next week or so, we'll declare general availability where SLAs apply, service officially ready to accept production workload, and the operational workload, keep the lights on type of work from the previous phases is at reasonable levels. We've determined that we are at reasonable levels, so we are proceeding with that. The other thing that's super important, especially for new folks on-call or folks that do not have a lot of context around how an organization is shaped, just do not know the people in a company, right? They don't have the tenure. It's having clear escalation lines. It's the worst when someone receives an alert, he's being the point of contact for an escalation, but they are not the ones actually knowing how to do something about the issue, and they have no way to identify who to triage to, right? So common challenges: who owns what, who is on call, when and how to escalate to. We found a simple way to improve on that by mandating every service to be registered in a central service inventory, using also APM service map to understand exactly what are the connection dependencies, either upstream or downstream of a given service, and also mandated that every alert generated by the system is attached with a runbook and proper routing to a service owning team. You cannot have an alert in Elastic Cloud nowadays without an attached runbook that is reviewed and also pushed to the correct team. We also created a chart of proactive and reactive flows for an alert or an incident or case management to be clear exactly what's the path that would be covered from someone receiving that page, and communicated that with the engineering teams and the support team to make sure that we are not missing any branch and any decision matrix. The componentronics were kind of big. Like I should have like a diagram there, but you can imagine how, like in big companies, things can be really complex. Like the escalation lines are really, really tricky, and getting that thing right is super important. And with that, and as a continuous improvement data point, we collected escalation rates from each and every step. And we were able to segment it per alert and understand if we need to do something about it if we see that an escalation rate is super high. That means that customer is having a bad time, an alert is hitting a specific team, and then they cannot do something about it, it gets escalated. That high escalation rate almost always means that there is a bug somewhere in the system that needs to be resolved. And by system, I mean the human system, not necessarily the software system. With that, we also had to really, really simplify and tone down our incident management processes. Our senior SRE leaders are still incident commanders for the very high severity incidents, but every engineering team is now able to manage and run their own incidents. In the past, we had a very verbose incident management guide, many severities, a complex decision matrix around what to do and when, and almost always it was just senior SREs or very tenured people that would just immediately react appropriately when in an incident. So we simplify the severity levels. We provide a common root cause analysis format for teams to follow. And we also did on-call training for development teams. We had a dedicated team, we call it a SRE resilience team, that would approach engineering leaders that were interested in getting on-call training. And together with their team, they would go through all the nits and bits and pieces of detail around managing an incident. With that, we also started collecting data around incident trends, and that would inform future service enhancements. We realized that the tooling that we have developed in-house was not good enough and not approachable enough for engineering teams, and we sought a vendor solution to simplify the flows in an incident management process and make them accessible to everyone. Furthermore, in order to empower engineering teams to feel more in control of their system, we supplied a set of systems that would help them in their everyday life and their companions in the software lifecycle. So we came up with an internal development portal that carries a service inventory and integrates with other systems like PagerDuty, connects back with our alerting framework to understand what's going on. We are providing a managed CI/CD pipeline. If you are to release software in Elastic Cloud, you need to be onboarded on that CI/CD pipeline. You don't need to manage it. You just need to write exactly what your tests are and how you build your software, and then define some criteria around where your service needs to be deployed. Right? Engineers tend to love GitOps. So we provide them a means to get software delivery just by issuing some commits and some ability to sometime override some defaults in some configuration. That just happens in production. Sometimes something goes wrong, you need to override something. We have a way to do it as configuration as code. We also came up with a system, our engineering productivity team came up with a system that provides some quality gates. Quality gates when releasing software with multiple inputs as checks. It can be end-to-end tests. It can be a simple metric check. It can be a manual approval type of check. Yeah, I authorized, you can go. Or an SLO burn rate check. If things look okay, when we are canaring a thing, progress it to the next environment and so on. Another thing that we realize is important is developers need to debug. SREs tend to have a high level of access, right? And sometimes they just, enter a machine through some execution system, get their diagnostics, and do some ad hoc analysis. We need to have a controlled way, secure way with respect to customer privacy and safety to provide that thing, and we did. We came up with a way for developers to define a runbook, some execution flow, and an execution system to go in and do what's needed. We're also providing vulnerability management, dependency scanning, supply chain checks, and all that. The outcome of that is that we helped ensure a more reliable, more low-risk type of deployment path for development teams. That really gave confidence for them to roll their software out. Another key difference compared to before, where SRE and SRE-related teams, engineering productivity teams, manage the release of the software, right? And that was like really a cultural mind shift, is that every engineering leader is now parroting that the main branch needs to always be deployable. That was a huge mind shift. In the past, when you have like a specific release cycles and all that, folks would tend to throw garbage in and then hope that by the time we were to release the software, the CI checks would pass, the QA environment checks would pass, and then things would promote to production. That was a very bad practice and doesn't help with a system that, just needs to keep moving faster and faster. So we also provided observability as a service for internal teams. They no longer need to care about managing their own observability solution. We give that for free. Being elastic, we use Elastic for observability, right? And we provided a self-service model. So all services in conformance of a specific spec have all of their observability signals automatically pushed to observability solution. So if you have your system instrumented with APM, if you are logging in a specific way, if you provide some metrics and points, if you want to have some profiling data pushed in our observability solution, you can just do it by some configuration and you are done. You're also able to define your own SLOs, dashboards, alerts as code, and through some GitOps management, everything is pushed upstream and everything is managed as code. We also provide a single pane of glass, and while every observability signal and data sources are spread across the globe, right, and each and every point of presence, developers still get this seamless experience of just one Kibana interface. They don't need to care about where exactly in the world data is. Just things appear on their screen. That's a core capability of Elasticsearch called cross-cluster search. We'll go that into detail. Now, the other thing that was key in the transformation is that we established SLOs as a common language. They act as a communication layer between, aligning across teams and business goals. And at a high level, we want them to translate roughly to a customer happiness level. It's true, though, that we do have like lower level SLOs, and it's about how systems fare, and it's important, especially when they are very critical dependencies to other systems upstream. The Elastic SRE team is maintaining a single pane of glass cluster across Elastic Cloud that connects over 180 clusters across the globe through this feature that I mentioned, cross-cluster search. It holds petabytes of data. It ingests over 500 terabytes a day. And as of 2 hours ago, we monitor over 900,000 SLOs across the globe. First, why did we build that system, right? Since we are responsible for each individual customer's deployment, we wanted to attach an SLO next to each and every cluster, or a set of SLOs, right? There are multiple SLOs around system behavior. And that starts to become a high cardinality type of problem, and we need to have a way to actually go about it, right? We used to have a process and a system to calculate SLIs and check for SLO conformance. It was kind of complex. It was an ETL processing job that then was then serving data back to Elasticsearch, and then we would view things on Kibana. So what we tried to do is simplify, try to come up with a system that does not require any other component other than Elasticsearch, and see how we would build the system. We try to have some type of materialized view in order to transform core data from data sources, convert them in a way that can be translated to SLIs, get them into another index, and then monitoring for SLO levels over there. You can think about it as an ETL job, where the extract phase is actually querying, is seeking Elasticsearch as a backend. The transform phase is manipulating data in a specific way, and the load phase is getting data back into Elasticsearch, right? That was great because in the end, it didn't require any additional service to be built or managed, and those transforms to save up the data allowed us to implement this, what we call group by feature, where you monitor instances of an application by a set of criteria across the globe to be super trivial for us. As such, we are now able to monitor each and every application and not be lost at the sea of aggregates. But we face some problems with the original design. Our system is very complex, a distributed system. Data lives on each and every point of presence. We need to have a way to bring the execution engine closer to the data. So the team developed a way to federate the SLOs in a cross-cluster search environment. The goal was to reduce the amount of query traffic between this overview cluster, this single pane of glass cluster, and the source data. So only the summarized data are queried via cross-cluster search, and the actual data remain on the individual points of presence. So we still have this same single pane of glass experience, but we still can also drill down to the exact data when needed. That allows us to scale that system horizontally to as many points of presence in whatever scale we need. That Elastic Cloud Overview cluster is what we know I think is one of the largest cross-cluster search environments, not by volume, let's say, of data carried or ingested, but just by how spread it is across the globe. Using transforms there extensively was a real battle test for the SLO product, and it was, I have some horror stories to share later. We hit every possible bug that we could hit, but that's great because now customers can also build something like that on their premises or on our cloud, having high confidence that it's really battle tested. That's a view, a current view. Obviously, not everything is 100%. It just happened to be in that screen, showing that as of an hour ago, we are close to 1 million SLOs being tracked. So they are growing. As you get more deployments and projects, things are just growing. Another important thing to keep the pressure, a healthy pressure on operational excellence, we introduce some venues where we discuss operational KPIs. So we came up with that high-level venue where C-levels would join along with VPs, Director of Engineering, technical leaders, and open to every engineer, really, right? We would discuss things around examining incidents, check around SLO compliance, how is our toil ratio going, what's the keep the lights on effort investment, and also doing post-mortem reviews, examining the action items and takeaways of recent post-mortems. We also use that venue as a vehicle to examine incident threat analysis and check for areas of improvement. The nice thing about it is that higher level one that happens weekly was an inspiration for other teams, lower level teams, at the organizational level or even at the lower team level, to come up with their own operational reviews. And suddenly at Elastic, you see many teams having their own operational reviews that go really deep in their service and their products, and in general has really changed the mind, the whole culture around operational excellence. It's now super cool to be worried about those things. Takeaways. There are some lessons learned. First, it's never too early to engage with other leaders to prepare for such a change. And when you find leaders that are on board with that change, you just give them the wheel. Let them drive. They know their organization better than you. They have their ways into convincing people, influencing people, and they are the best ambassadors for such a radical shift in operations. You also need to simplify and communicate strategy, both on the business side of things and on the architecture side of things. It's important for engineers to understand exactly why we're doing that change, why it matters, why we are re-architecting, and then when they know their work suddenly has more depth, more meaning, it's more fulfilling. They understand exactly the type of impact they have to the business and that their work is valued. By doing so, and by mentioning that operational excellence is a key element that is being reviewed, right? It also becomes important for their career progression paths. It also becomes an incentive for folks to focus on that because they are being rewarded. It's also important to know your first team. Your first team is not the team that directly reports to you or the team that's below you, right? Whatever. I don't have reports, but I'm at a high level of seniority, so there are folks, teams beneath. My first team is peers of mine, other distinguished engineers, right? I need to do what's best for them. I need to fight for them. I need to do whatever is best for their partner, their VPs, and what have you. And in that way, you don't get trapped into politics, you don't get trapped into lower level issues, and it's always for the best. Have that mentality, know your first team, ask your teams to know their first team, and when you do that, things tend to go much, much smoother, especially when you are navigating such large changes. The other thing is keep parroting, keep saying all the time that reliability is a system property. It's not an afterthought. Folks need to design with reliability in mind, and that really helps. The best place to start designing for reliability is right at the start. So it's important to just keep repeating that. The other thing is that you need to have supporting systems and processes. I've listed a set of systems that we set in place in order to enable folks to carry the pager. So give those things for free. Folks need to say, okay, what's in it for me to go on that journey, and you need to be able to immediately give like a list of 10 bullet points. Hey, if you do this, you get this and that and that and that, and you only need to worry about writing your code, providing great customer experience and nothing else, none of the other garbage. Lastly, the main lesson learned is that empowered engineering teams actually love being on call. They love it. If they are empowered, if they can fix their things, if they can monitor their things right, properly, they just love it. They understand that the work has impact. It's cool to fix bugs. It's cool to improve performance. They just love it. And with that, thank you.